The rocket will be about 7 meters. It will have a 5-meter oxygen tank, and then combustion chambers about 1 meter, that's 6 meters. Then it will have a area for a parachute and a cone, you know, so it's going to be about 7 meters. It's impossible for it to hit anything, even if it rotates. It can only, at worst case scenario, glide along one of these corners. This arm here bolts down the bottom, and you can see a lot of holes there, and each of those holes is a different angle, so we can angle this out to sea. Oh, it'll fly.
So what have we got going on here, Michael?
Well, this is a prototype to a smart throttle. So this is a throttle, fits above the combustion chamber, and its job, working with this Arduino, will be to deliver low pressure oxygen, ignite that low pressure oxygen, burn the low pressure oxygen for a certain amount of time, then open up to the full high pressure oxygen, which could be 650 to 1000 psi for the launch. So this is a demonstration of how it's all going to work, so we'll simulate that with compressed air. Okay, so that's how it would be inside the rocket. This LED here will represent igniter being ignited, so in the sequence of events. We can be 2 kilometers away if we want to, and then we'll send a code through to that box which Dangerous Dave put together, and that will send a signal to the rocket. The last test we did, everything blew up and was on fire. We sent a signal with that, and it covered everything in carbon dioxide powder. Same technology, it's very good now, we're tested, we're confident with it. So everything on the rocket will be self-contained. First, the chamber being filled with low pressure oxygen. Then you'll see this light up, which is simulating igniter being ignited. So we ignite that low pressure that we've just put in, and then it should run for 2 or 3 seconds, or whatever we set it at, to get the core ABS burning, and then it should open up with full high pressure oxygen. So that's what should be going on here. So we send in the signal now.